The accelerated development of artificial intelligence and robotics allows humans to augment and to increase our intellectual output. With research and development centers in Miami and Medellin, the mission is to provide solutions by applying our technology offerings to product development with emphasis in medical, pulmonary ventilator systems, such as the engineering prototype illustrated in this video. The ventilator paradigm is controlled by a sophisticated neuromorphic embedded system to allow exact adaptation of pressure and flow characteristics. Fine-tuned ventilator settings also serve to make ventilation more tolerable and comfortable. Non-invasive methods such as continuous passive airways pressure and non-invasive ventilation, which are adequate for patients who require ventilator only while sleeping and resting, mainly employ the nasal mask. The artificial intelligence microprocessor pressure ventilator consists of a compressible air reservoir, air and oxygen supplies, a set of valves and tubes, and a disposable patient circuit. The air reservoir is pneumatically compressed several times a minute to deliver room air and air-oxygen mixture. The ventilator with a flow valve adjusting pressure to meet patient-specific parameters. When overpressure is released, the patient will exhale passively due to the lungs' elasticity, the exhausted air being released usually through a one-way valve within the patient circuit called the patient manifold. Neuromorphic engineering technology has played a relevant role in improving the technical performance of the ventilators and also in contributing to a better understanding of respiratory physiology and pathophysiology and of how different ventilation strategies interact with the respiratory system. As volume measurements are obtained by digital integration of the flow signals, the signal processing also significantly contributes to volume accuracy by compensating for drift and leaks, especially during non-invasive ventilation, where leak estimation and compensation algorithms play a significant role. The firmware resides on the main digital controller, whose function is to monitor and control both the analog and digital sections. The neuromorphic embedded microprocessor allows the implementation of sophisticated signal processing of the measurements provided by sensors, leading not only to a better measurement accuracy and better rejection of noise and artifacts. It also deals with the generation of new information by appropriately computing and integrating several variables. These variables expanded information that can be used by the ventilator to optimize the ventilation parameters.